Alright, hi, welcome back, and today I'm going to be solving the USACO 2017 January contest over Problem 1 Cow Dance Show. So let's read the problem. After several months of rehearsal, the cows are just about ready to put on their annual dance performance. This year they're performing the famous bovine ballet, Cowphilia. The only aspect of the show that remains to be determined is the size of the stage. So we automatically know here by reading this one sentence that we need to look for the size. A size of stage size K can support K cows dancing simultaneously, and 9 cows in the herd up to 10,000 are conveniently numbered 1 through n in the order in which they must appear in the dance. Okay, and each cow I plans to dance for a specific duration of time d of I. Additionally, cows 1 through K appear on stage and start dancing. When the first of these cows completes her part, she leaves the stage and cow K plus 1 immediately starts dancing, and so on. So there are always K cows dancing until at the end of the show when we start to run out of cows. And the show ends when the last cow completes her dancing part at time t. Clearly, the larger value of t, the smaller the value of t, but since the show can't last too long, you are given an input as the upper bound t, specifying the largest possible value of t. Subject to this constraint, please determine the smallest possible value of k. Okay, so what does this problem want? Well, there's a certain stage, right? And there's going to be this line of cows that are waiting to go on stage. And each cow is going to perform for a specific duration of time. And this problem wants to know the minimum size of the stage that ensures that the ballet ends before a certain amount of time, so time t. And so let's try looking at the input first. So, okay, so the first number is n, and the next one is t, which is the maximum amount of time. So we see that there are 5 cows, and there is 8 time available right now. Then the next n lines give the duration, which means that the numbers there are going to be 5 cows, and the first cow wants to go up for 4, let's say 4 minutes. The second wants to go up for 7, and the third for 8, and so on. And we have to print out the smallest value of k, such that the dance performance will take no more than t max units of time. So I'm gonna show this on a spreadsheet for a quick second, so we can see how we can solve this problem. So since we know that the sample output is 4, let's just try the values of k as 3, 4, and 5 for now. So 5 cows, max time equals 8, right? And the cows are 4, and then 7, and then 8, 6, and then back to 4. Okay, so if k equals 1, so k is the size of the stage, right? And if k equals, let's just do 3 for now, and let's try 3, 4, and 5. So if k equals 3, first of all, that means the stage is its size 3, right? Which means that initially 3 cows can go upon the stage. So 8, 7, and 4 can all go on the stage. So 4, 7, and 8, first 3 cows all go on stage. After that, after 4 minutes, then this first cow is done performing. So then this next cow, and it has to be in the order that it's specified in the input. So it's not like this cow can go after this cow. It has to be this cow. So after 4 minutes, the fourth cow enters, and the ordering becomes so in index 1, there's going to be a cow which has 6 minutes left now, and in index 2, there's going to be 7, but 4 minutes have passed, so it's going to be 3. And then at In the last place, we're going to have a cow that has 4 minutes remaining in their time. That's not what I wanted. 6, 3, 4. Oh, okay. 6, 3, 4. Dot, dot, dot. Okay. And then after this, after 3 minutes pass, after 3 minutes, the last cow enters, and it becomes it becomes 3, and then this last cow of 4 goes into the middle spot, so it becomes 3, 4, and 4. And then at the end, we sum up 4, 3, and then the maximum time left, so 4. And that's going to give us 11, which is greater than max time, which equals 8, so it doesn't work. Now, I'm not going to try 5 because I see that this takes a lot of time to do, but let's just try k equals 4 now and see if it works. If k equals 4, then first, 4 cows enter the stage, right? So first 4 cows go on stage, and so the stage is 4, 7, 8, and 6. And then, after 4 minutes pass, the last cow goes on stage. So we subtract 4 from each of these, but the first one becomes 0, so we add another one. So it looks a little confusing, but it's another cow at the end replacing the first cow. So it's 4, 3, 4, and then 2. Since we're subtracting 4 from each of these, but since this becomes 0, the last cow is replacing the first cow. And then the maximum is 4, so we add 4. So 4 minutes plus 4 sometime equals 4 plus the maximum of here, which is 4, right? Which equals 8, which is less than or equal to the max time, which equals 8. So yeah, k equals 4 works. Okay, now that we get the general gist of the problem, we see that okay, the main thing we're trying to do is we're trying to find the optimal size of the stage, right? But there's clearly a problem because the size of the stage can be any number from n equals 1 to n equals 10,000. And this check alone is going to, in the worst case scenario, it's going to cycle through each of the cows and see what time each cow is going to go in. So when we multiply 10 to the power of 100, 10,000 times 10,000, that's going to exceed our time. And one thing we notice about the problem is that we're trying to find k, which is the size of the stage, right? And we see that if we're given a value and k is too large, then we automatically know that we can try testing smaller values of k. And if we have a low value of k and it doesn't work, which basically means that the size of the stage does not support enough cows to complete the show within time t, we're going to need a bigger stage. So by checking if a certain stage size works, we can determine if a larger or smaller stage size would also work. And what I'm basically trying to say after all that is that we can use a binary search to try and look for the size k of the stage. And I've done a binary search in a lot of other videos, but if you guys don't really remember it, it's basically you have an if you remember this, you can just skip over this, but it's where you basically do a guessing game where you know that k is going to be in between 1 and 10,000, right? And what that basically means is that you can first check the average of 1 and 10,000 and 5, which is 5,000, and then using 5,000 you can check if the stage size needs to be larger or smaller. And if it needs to be larger, we can set the range to 5,000 to 10,000, and if it's smaller, we can set the range to 1,000 to 5,000, and keep on doing that until we decrease the range to an interval of like 0, basically, which means we find the most optimal number. And the code is basically there's a low, which equals 1 in this case, there's a high, which equals n in this case, and there's going to be a middle number. And while the low number is less than or equal to the high number, what we're going to be doing is we're going to be setting middle to the average. Mid equals low plus high over 2, which is the average formula. And then we put a function which basically finds if the stage size needs to be bigger or smaller. So if check mid, which is a separate function, and if it does work, then we set answer to that value. So we're updating the optimal size of the stage as we go along. And then we can change the range by either changing the low value or the high value. And in this case, we want the lowest value of k, which means that if this check mid returns true, that means we can start looking for smaller values of k of the stage, smaller sizes of the stage. So we're going to be setting high to mid minus 1, which basically decreases the range from 1 to mid minus 1 inclusive. And then else, we can do low equals mid plus 1, which does the opposite. It looks for higher numbers. And at what point the high and the low are going to switch, which causes the while loop to break out. And at the end, we just have to print out answer. So I'm going to start coding now. I hope this entire thing makes sense to you guys. And yeah, I'm going to have it open so we can look at it as we go along and solve it. So let's remember the input n, k, and then n lines. So first, we have to import java.util and io. Oh yeah, what's the file name? It's cowdance. I'll have to remember that. And public class USACO cowdance show. So they're going to be n lines, so let's just use a buffered reader, which is going to get the lines, input the lines really fast, and also get a string tokenizer for the very first line. Let's get a print writer to print out the most optimal value of k, and then we need integers n. Oh, it's not k, by the way, it's the second value is t, which is the maximum time. So int n, t, we're going to need an array to store all the values. So let's set it as a, and also answer. So I'm making my main, and what we have to do now is we have to set up the buffer reader. So in equals new buffered reader. For now, I'll set it to an input stream reader, which gets it from the console. Wait, where is my console anyway? Window, perspective, show view, console. Okay, there's my console. Okay, it's fine now. And then, okay, so first we need a string tokenizer to get in the first line, right? So st equals new string tokenizer in dot read line, and then we need integers n and t. So n equals integer dot parse in. Oh, st dot next, and the same exact thing for g. Yes. Then we have to fill in the array, right? And that basically gets the input nice. Okay, now we're ready to do the binary search algorithm here. So int low equals 1, right? Because that's the lowest possible value of k. Int high equals n. Int mid equals... Actually, let's just set it as nothing for now. And while low is less than or equal to high, mid is the average, so mid equals low plus high divided by 2. And what we have to do is we have to create a separate function that checks if we need to increase or decrease the stage size. So if check mid answer equals mid, high equals mid minus 1. Since if the stage size works, then we want to look for smaller values of k. And if it doesn't work, then we're looking for higher values of k. So we change the range to higher values. At the end, we just print out answer. And now's the tricky part. What we have to do is we have to create some kind of function that gets in a value of k and determines if the most optimal way of placing the cows makes the most optimal way of placing the cows ensures that uh, the entire ballet ends before time t. So it needs to be Boolean, right? Since we're returning a Boolean that says if it works or not. And okay, so first of all, we're gonna need some kind of data set, right? We're going to need a data set that represents the stage. And we're not sure what we're going to call it yet, but let's call it like data set stage. And I know that that doesn't exist right now, but I'm going to use it as a placeholder for now, and I'm going to show um, what kind of uh, what kind of structure we might need to use as code this function. So first of all, the first k cows or the first mid cows are able to go up on stage, right? Because initially the stage is empty, but as the show starts, all the cows can go on stage. So I is less than mid. Actually, let's change this to k. K is going to be the size of the stage. So first k cows are able to go up to the stage. And we don't have to worry about it getting out of bounds exception, because this value of k is always going to be less than or equal to n, because high is n. And we're going to be adding that to stage, and then for each of the remaining cows, I equals k, right? I is less than n, I plus. What we can do is we can check which cow is the lowest. One, check which cow ends the earliest in stage. And then two, we can add the next cow's time to that cow's time. And what this basically does is, instead of like updating the values one by one, what we can do is instead of subtracting 4 from each of these, we can we can keep all these values, but just add 4 to the very first value. And that way it'll be 8 8786, and it's going to take 8 times. And that's a lot more efficient than looking at all of the values. And when we add them all up, we want to see if each of the values are less than or equal to t. So, but the problem is we want to know which cow is going to finish their performance the first, the earliest. And a neat way we can do that is using a type of queue called the priority queue, which basically stores this. It keeps track of which integer inside of it is the minimum. And what happens is when you do when you pop out one of the elements from the priority queue, it's going to pop out the lowest value. But since it's still a queue, it's going to be fast, since it's going to make sure that the lowest value is in the first index, but all the other indexes aren't sorted at all. So int finishes first equals stage.pull. Int next cow equals a of I, right? Because that's going to be, we're looking at all the remaining cows in this for loop. And if the finishes first cow plus the next cow, so if the sum of their times are greater than t, which is the maximum time, then we return false. And if we don't return false, then we just add finishes first plus next cow. And then we return true. Okay. It should work. Okay, it was 4. So I'm going to try taking the actual scanner and contriter. Equals new buffer reader, new file reader. Oops. Cadence dot in equals new print writer cadence dot out. And yes, I'm recording this at 1 a.m. Anyway, yeah, let's try submitting it. Oh, nice, it's working. And as you can see, it's compiling in an extremely fast amount of time because this binary search algorithm is actually really effective in decreasing your time when you're trying to find a specific value that's the most efficient. So yeah, all test cases passed. Here's the code again. And I hope this video helped you understand this problem and solve it. And yeah, thanks for watching.